Well, hello and welcome everybody. Very nice to see all of you in person, and we have up to 90 or 95 signed up for online. So welcome to our hybrid meeting to celebrate the 50th anniversary of the Climatic Research Unit here at UEA, or CRU, or CRU as we call it for short. So it's nice to see you all here, and I'm going to say a few opening words, give you a quick overview of some of the key CRU contributions over the last 50 years. I'm Tim Osborns, for those who don't know me, Director of the Climatic Research Unit. And I want to take us back first of all to the very start. So this is the opening lines of the proposal to found the Climatic Research Unit here at UEA. And this is what it said at the start. Among the many environmental changes brought about by man, few are as far-reaching as those that affect climate. It is now reliably established that the burning of fossil fuel has increased atmospheric CO2 levels, and it has been claimed that the worldwide warming trend observed through to the 1940s was brought about by the greenhouse effect of that increased CO2. So right at the start, CO2 front and centre, but also it went on to emphasise there was much we didn't know. We didn't know how large the CO2 effect, and we didn't know, as we do now, that CO2 would come to dominate over the natural and other anthropogenic causes of climate change. We know that now, of course, not least because of the research that the Climatic Research Unit has contributed to over this 50-year period in establishing how much and how fast we're warming, in reconstructing natural variability further back in the past, in determining the relative magnitudes of different drivers of climate change, and in developing models to make predictions of the future. Prediction must depend upon understanding, is what the proposal said. I think that's very true. And it also went on to emphasise that this is not just an academic topic. Future changes in climate were crucial for society. And that brings us to the subject of today's meeting, is about from climate science to climate action. So we're going to be talking today about how CRU and how others in the climate community have done that. So here's a few facts and figures from 50 years of the Climatic Research Unit. We've published our science, we've told the world about our climate research, 1,760 articles published in scientific journals, books and reports over that period. And our contribution to scientific understanding of climate change has been widely recognised, not least through the fact that this work we published has been cited by many other people around the world, 141,000 citations to date. And we've told policymakers about the science of climate change. So the Intergovernmental Panel on Climate Change provides the scientific basis for international action on climate change, such as the Paris Agreement. And Climatic Research Unit researchers have contributed to all of the major IPCC assessments, from the first one in 1990 through to the sixth one published this year and last year. 28 individual contributions over those 6 assessment cycles. So that's some facts and figures, but now a little bit more detail about this. So what we're dealing with is this issue here. We have the drivers of climate change, whether they're natural or changes in society, and our emissions of greenhouse gases and other climate drivers, determined by economy, technology, energy, demographics, and so on. And then on the right-hand side is where we want to get to. We want to go from the beginning on the left-hand side to saying something useful about future climate. It could be about the global temperature, because that's the metric that's used for things like the Paris Agreement goals. It could be about highly detailed future climates that decision makers of all types, whether they're in the public sector, the private sector, policymakers, they want that information. And I put an asterisk there, the future climate, it includes the translation of what is sometimes quite idealized scientific information to make it relevant for those decision makers and policymakers. So how do we get from there to there? Well, there's a huge cloud of stuff in between. And CRU, through our research, have contributed to this. A lot of it is science, but I should say that it's not science on its own. We've learned and indeed pioneered on the bottom left here, the fact that you need to co-produce this work by interacting with users and stakeholders. And I think our first two speakers perhaps will reflect upon some of those aspects as well as the scientific ones. Of course, we use models to make this translation from the inputs through to the outputs. And one of the interesting things there is that we have different types of models. We have a hierarchy of models, from simple ones through to more complex ones. We've used all types of models, but we're particularly known, I think, for developing simple or reduced complexity Earth system models. Malta Meinshausen will talk later on about the MAGIC model in particular that was originally developed here at UEA by Tom Wigley and Sarah Raper. And one of the interesting things for me is that as you look through the IPCC reports, and if you're familiar with how they were developed, it seemed to me that early on the simpler models had to be used because that was all that we had that was dealing with the policy relevant scenarios. The complex models have been used for some kind of simplistic understanding of the climate system. And then as you went through to the second, third, maybe even the fourth assessment reports of the IPCC, it was sort of seemed to be that these simple models were said, well, we'll carry on using them for the moment, but the complex models are getting better all the time, and eventually we can dump the simple models and use the complex models because they'll do everything we need to do. Now, I think in the fifth and sixth assessment reports, it became clear that actually you can't get away from having this hierarchy of models, because no matter how good the complex models get, if you want to run them 10,000 times to explore 100 different scenarios of our future emissions of carbon dioxide and 1,000 different combinations of climate model parameters, you need to explore the uncertainty in those projections. You really need to bring together the complex models. You need to bring together the simple models. And for many years, the complex models that mostly were used didn't include an interactive carbon cycle. And if you're interested in working out what our available carbon budget is and so on, you need to know how climate change will affect the fluxes of carbon in and out of the oceans and the terrestrial biosphere. And again, the reduced form or simple models could do that. And they could also bring together observations and models better. Models are not perfect, and therefore they don't match the observations perfectly. And what happens if you want to have a seamless prediction through from the past to the future that matches the observations, but also brings in the information from these complex models of the future. Other aspects there which were important, for example, Tom Wigley demonstrated that you could, on the simpler models, you could more easily run them backwards. So if you had a target, suppose you wanted to stabilize carbon dioxide at a certain concentration in the atmosphere to avoid dangerous climate change, you could run the simple models backwards more easily to say what emissions of carbon dioxide would lead to that stabilization. The other cloud of points on the bottom right there is about getting this detail in there. And again, if you look back at our work, it's really quite inspiring how much we pioneered in terms of the impact model, but also the downscaling of this information from complex models, which was on a fairly coarse resolution, downscaling to the local detail that you need for some of these impact modeling work. So again, CRU was a pioneer of that using statistical downscaling, but also a pioneer of using statistical weather generators in a climate change sense. And other emulators of complex models, such as pattern scaling, were things that were developed and taken forward very much within the Climatic Research Unit. So with that, I'll now turn to the program today. We've got a really great set of speakers. We've split this into 3 sessions. The first is about climate information for society. And I think these 2 talks probably are somewhat more reflective about what we've learned from some of the past research that's been done. Then we'll have a break. Then we'll have 2 sessions after the break. Our climate futures, where we have talks from some of our current PhD students. And then moving into session 3, where we're going to talk about what we need to do about climate change. So thank you for listening to my welcome.